Thank you, folks, for being here. We will start the talk in about a minute. So, waiting for like a few more folks to join, and then we will start. All right. Good evening, everyone. My name is Raghunath. I work as an independent consultant, and I work mostly on the Android platform with Kotlin. But then in recent days, I've mostly specialized in working with legacy software and like software that is really hard to maintain. So those are my areas of specialization. And I also help organizations build robust software. So this is a series of talks, and this is the last talk in this series that we've done so far. And for those who have attended the session previously, welcome back. Glad to have you here. And for those who are attending this session for the first time, you don't have to worry because all of these talks are completely independent of each other. You can always go back and watch them at your own pace. So let's get started. Before we get in, I just want to give you a small recap of what happened in the past couple of sessions. So in the first session, we were talking a lot about the robustness principle and how to use Kotlin's type system to create algebraic data types. We also looked some of the ideas from the functional programming world, such as total and partial functions. And we also came up with techniques on how you can minimize defensive programming for your consumers. In the sense, like if you're a author like of a library or like any part of your system that is used by other people in your team, you can design it in such a way that they don't really have to do a lot of defensive programming when using your application or your module, right? And then we also saw how to use the type system to short circuit failures, and it's also known as failing fast. And finally, like we ended up with avoiding primitive obsession and why it's bad for you, and what are the things that you can do to prevent it in your code base. So that was episode 1. And episode 2 was mostly about exceptions and boundaries. So we were looking at some of the anti-patterns and while handling exceptions or throwing exceptions. We were also looking into a couple of patterns that will help you handle these exceptions. The first one is called the tester-doer pattern, and then the try-parse pattern. And then we were also looking into ideas on how you can take these exceptions, convert them into domain level objects so that you can have more mean context around these exceptions, right? And then we also talked a little bit briefly about values as boundaries. And in today's talk, most of it would be around this, right? Like how you design systems and how you design your boundaries and how they actually affects your tests, right? And then we also saw about like the kind of architectures that use values as boundaries, right? So if you're interested in any of these talks, they're already available here. The Meet Kotlin folks have made a nice playlist where you can go and watch these talks. And here is a QR code as well as a bit.ly link that you can go and visit later. That's the end of recap. And then now I also want to talk about like why did I decide to do this talk, right? So first thing, like this talk is not going to be about APIs. It's not going to be about how to write tests or why you should write tests. Like I think like there are like a lot of talks around that. The reason why I am doing this talk is I have been going through this testing journey for almost like 7-8 years now. But then during my initial days, I did not take it seriously. Like say, for example, I considered testing seriously maybe in around 2017. I think it's the past 5 years. And it's been like very hard, a journey on my own, like exploring a lot of different things, a lot of different ideas from different languages, different speakers, different like thought leaders. And then I had to string together a piece of ideas that actually helped me to become better at testing, right? So now, one, if you're new to testing, then I want you to know that the way how you learn to build software, that is one part of your career, right? And the moment when you really understand how testing has an impact, that is your second part of your career, right? And for engineers who are already experienced and who are already like have attained a plateau on testing, and then you feel like, okay, there is testing is boring, or like testing, there is no more to testing, right? So then I want to introduce a few ideas to you that will actually change the way how you look into testing, and then maybe probably consider it a little bit more, right? So the way how we are going to go about this is I'm going to show you example, a very simple example, and then I'll show you how like little changes can actually affect the design of your code and also increase costs in testing, right? So testing on the grassroots level, at least in my opinion, of course, like there are other benefits like safety and safety and maintainability, all of that all stuff. But then at a very fundamental level, testing is a way to test the design of your software, right? And most of the time when we talk about design, people or like almost all of us, we are very subjective about the design that we bring in, right? We think designs that are familiar or more or well designed than the designs that we're not familiar with, right? So testing is basically a idea to design, right? Like, are you designing your software well enough? And that is like writing a test is actually a true test of how well designed your software is, right? So this is mostly about like a design talk more than like a testing talk. But then we'll also look into a bunch of ideas that you may or may not be familiar with. So let's say this is a scenario that you are in. So a startup has hired you, and then they want you to build a feature that will send reminder emails to their attendees, right? So that's the scenario. That's what we are trying to do. And more often than not, we are not usually in such situations, right? Like we don't get to write new software as much as we like at least in the real world. We are often hired by organizations that want to extend their existing software or like maintain or old software, right? Like that's what we are hired, like bug fixing and all of that. So this is one of the rare scenarios where you get to build a new feature, right? And probably after a couple of weeks that it is no longer a new feature. Okay, let's see how we're going to go about this. This is a hypothetical implementation of one of the things that I like that will help us solve this problem. It's a very hypothetical implementation, does not represent the real world. It's just to drive the point across. So let's say we have this class called event manager, right? And this class has this function called send reminder. It's a very simple function. So let's take a closer look at it. If you look at event manager, our objective is to send emails to potential participants who have registered for an event, right? So then probably you have some of these information in the database. So you have to query the database, and then you also have to send mail, right? And like all we have learned is like you can't put too many things in the same place, right? And that's where we talk about single responsibility principle. So in this case, what we're going to do is we're going to like put these responsibilities in their appropriate places. So we have a event DAO, which is going to access the database. And then there is also a mailer class that is going to send the email for us, right? So right now we say, hey, we have an event manager, and then we also have two dependencies that the event manager requires to accomplish this task. Now, if you look at the send reminder function, it's a simple function. It takes an event as a parameter. And if you look at this, we have the first statement is basically querying the database. So we're going to say, hey, let me go and look into the database and then see who are all the people who have registered for this event, right? And you just do that by querying the database. And the second thing that we are going to do is we're going to find out who the potential attendees are, right? So what we are doing here is we're going to look at the list of all the registrations and then see if this person has either replied with a yes or a maybe, and these are the participants that we're going to email, right? And the last thing is basically the sending out the email itself, right? We're saying, hey, mailer, these are all the attendees, go, and this is their email, this is the reminder that I want you to send, and then we're going to send an email, right? That's all there is. It's a very simple class. There's nothing fancy going on here. Now you've done this, you've shipped it, and then here is the news, right? And it looks like apparently your company is losing a lot of money because there are like a lot of bugs in production, like from code that other people wrote, not necessarily the code that we wrote right now, right? So all the bug fixes in production due to other people's code. So like the team has said, like, hey, the best way to solve for this is to write tests, right? And now, like, what happens is typically you have a project manager or an engineering manager that is asking you to say, hey, you know what, like these are the modules that you own. Why don't you write tests for them, right? So now we're going to say, okay, this sounds good. Like now I'm supposed to write tests. And now we also have to remember the fact that we're writing tests after writing the production code, right? So this is actually writing tests after you've written your production code, which is, I think, mostly common in most organizations. So now let's think about it, right? Like now you have implemented this feature. Now, if you want to write tests, the first thing you probably would do, because since this is a feature that you have already built, you're going to think about all the different scenarios that this feature should work on, right? So you're going to say, okay, I need to see what happens when there are no registrations. I have to see a situation where all of them have RSP PDS, and then what happens when everyone has said no? Maybe all of them said maybe, and now there is a mix of yes, no, and maybes, right? So these are all the situations that we're going to write tests for. So let's go and write a test for the first scenario, which is like there are no registrations, right? So this is a class that we have, and you can already see that we have a couple of dependencies. We have a DAO and we have a mailer, right? So now this is a very simple test. So it says, don't send emails when there are no registrants, right? That is the scenario that we're trying to test. And this is a nice little Kotlin feature where you can enclose your function name within backticks. So that way you can have spaces between them. So unlike in other languages, you don't really have to use underscores or hyphens. You can write tests that are really readable, and then they're like also like look like documentation, right? So what's going on here? So the first thing is we know like we need a DAO and a mailer, right? And there are cases where you can actually use the real thing, but sometimes it's not advisable to use the real thing. Like say, for example, if you're going to use a database is actually a shared state. So now if you're running tests on a shared state, then you may have to like also be responsible for making sure that the state is correct every time you execute the test, right? So in this case, we don't really want to like use an actual database. We don't really want to use an actual mailer. So we're going to use something that looks like a database or like looks and behaves like a mailer, right? So we're saying, hey, this is what we're going to do. And we're going to create a new event manager. And this is a real one, right? And unlike the previous two dependencies, this is a real object. So what you're doing now is you're going to say, hey, DAO is not actually a real object, but then if someone is going to call this function on it, you're going to return an empty list, right? Because that's what we're trying to test. We're going to test if, okay, if there are no registrants, then just return an empty list, right? And then we have an event. So this part of the code base that you're looking at is basically you are setting up the things that you need to test your event manager, right? So this is basically your setup. And here you have a send reminder call. This is the function that we're trying to test. And then we're seeing, okay, like just make sure that the mailer does not get any calls, like or does not make any receive any calls from other objects in the system, right? So that's how we have tested it, right? So it's a fairly simple test. You don't really have to understand this if you don't know already. If you're already doing this, then like I think like most of you should be doing this. So I'm not going to explain the API. That's not the point here, right? Like we just want to make sure how design can affect the way how you write tests, right? And then like there's again a simple test. Let's another test here. So again, we're going to email only those who RSVP'd yes or maybe. So here we have a list of registrants. Some of them have replied yes, some of them no, and some of them maybe, right? Again, we're doing the same thing, like we're telling this object to behave like a real object. And we're going to call this function. And then we are saying, hey, the mailer should have received a call with these parameters. So you should only mail people who have responded yes or maybe. And then we should not have any more interactions, right? The last line is verify no more interaction, which is basically called as a negative assertion. So when you're writing tests, you can have assertions, which are like saying, hey, this should have happened. And then you can also write things that says this should not have happened, right? So here in this case, we have three different verification assertion statements going on, but they assert a single idea, right? So if you have written a test that has only one assert statement, which is like amazing. But in cases where you have multiple things, it's okay as long as they're testing the same idea, right? Here in this case, we're testing the same idea, which is basically only those who have RSP'd yes and no should receive the mail, right? So this is one idea. And this test looks a lot smaller than the previous one because I've gotten rid of the duplicates, right? Like you can see like the mocking, you don't see any mocking calls going on here. You don't see the real event manager getting created. You also don't see the event object here, right? So that way, this test looks a lot more simpler. So now we have a couple of tests, and I'm not going to write the rest of them because like that's how like the rest of them would probably look like the last test we wrote, right? Like for all of that. So now what you encountered or like what you witnessed is called as behavior testing, right? So in software development, like especially when it comes to testing, when we talk about behavior testing, we talk about sending messages, right? Like in especially in object-oriented programming, we have different objects, and then the way how these objects communicate with one another is by sending messages, right? And programming languages implement them through method calls, right? For instance, here we have three different things. Like we have obviously the event manager, and then we have the event DAO, and then the mailer, right? And the event manager is actually like if you see solid arrows where data is being passed between the two, and the dotted line is to just say that the control flow has completed, right? So the mailer will return back, like it's a void type when you're sending an email. So it's just going to tell you, hey, like you asked me to do this, I'm done with this. Now the control is up to you. Go ahead and do whatever you want to do, right? So now the event manager is the system under test. So this is the component that we're interested in, and this is what we're trying to test. And then the other two things are called collaborators, right? These are all dependencies. So these are things that actually play an active role when we're trying to test the event manager itself, right? So in this case, when we're writing a test, we have the actual system under test, which is a real object, and then we also have a couple of collaborators, right? So now collaborators may be a real thing, but that's depends on how simple your collaborator is, or it can sort of be like a real thing, right? It doesn't really have to be real. And let's now, in this case, we are dealing with sort of a real thing. And when you need a collaborator that does not have to be real, but have to have some behavior that are real, you can use different ways, like different kinds of things to do this, right? So you have stubs, mocks, fakes, dummies, spies. So they have different roles to play. So this is part of your behavior testing methodology, right? So behavior testing is basically telling, can these objects talk to one another, and what object is talking to which one, right? So that is basically behavior testing. It just tests the behavior of your system. So different ways to do this, and Martin Fowler's article has a very good, good information on when to use these things and what they mean, right? So I'm not going to explain this here. So let's look at the current event manager design. So if you look at the current event manager, it encapsulates business logic. So when I talk about business logic, it's about who should be notified, right? Like who are all the participants that need to be notified. That's what we're talking about when we talk about business logic, because this has some real meaning in your system, right? It's domain knowledge that should be encoded properly in your system, right? So now this is the piece of logic that we're talking about, right? So this is the one that tells who are all the people that are eligible to be notified, right? Or like those are the people who really want to be notified. So this is the business logic that is also part of our event manager, right? The next thing is coordination logic. So when we talk about coordination logic, who is talking to who, right? And in what sequence, right? So in this case, we want the event manager to talk to the database first, get a list of participants, and then once it has a list of potential people, then it has to talk to the mailer and send message to the mailer, right? So we have two different things, and both of these need to be tested. So if you talk about the coordination logic, it's basically like the event manager talking to the database through the DAO, and it's also like sending out emails through the mailer, right? So we have two separate things, and these two need to be tested. But the event manager has its own design, right? It has its own design. So how are we going to test the business logic, right? So the way how we're going to test the business logic is with the current implementation of the event manager, there is no way we can directly test the business logic, right? So we use the mailer as a proxy to test this business logic. Like say, for example, let's say there are no registrants. How do we test this business logic is working properly, right? So in that case, you're saying nobody receives an email, right? Okay, that sounds fair, and sometimes you may also feel that's okay, right? And then how do we know like only people who responded S received the email, right? And that also we are doing through the mailer. So we are not directly testing the business logic. We're using a proxy to test this business logic, right? And the current design only allows us to test it in this way. Like there is no other way to go and test it. So yeah, and then we also have a negative assertion over here, right? So that's how we're testing the business logic. So now how do we test the coordination logic, right? And it's not surprising, the coordination logic is also tested along with the business logic, right? So this is basically, we have 5 different scenarios for the business logic, and we are testing that through a proxy, which is the mailer. And then we also have 5 tests that are also testing the coordination logic, right? So you're already seeing duplication in terms of testing, right? So you see, we use the same thing to test the business logic, and we're also using the same thing to test the coordination logic, right? So at this point, you can already realize that there are different responsibilities, but then they're being tested by the same mechanism, right? So if the business logic changes, then there are going to be a lot of broken tests. And most of the time, if you are noticing code base says with ignore test, or you're trying to make changes to your code and then like a lot of tests are breaking, then the chances are that your code base is your test cases are coupled with your production code, right? And this is one such example. So we get a do-over, right? So now someone says, hey, you know what, if you have one more chance, we have written tests, but then these tests are fragile because every time when I decide who the potential attendees are, my tests are breaking because they're coupled with the test, right? I'm going to give you one more chance to do this over, right? So now we have a do-over. Let's see how we can actually change the way how this can be written, right? So this is the original piece of code that we wrote, right? And this is the new code that we have written, right? And don't be surprised if it looks very similar. It's just like one line of change, right? So this is the only change that we have seen here, right? And you'll see why this change is important and how it affects the way how we are writing tests. So if we take a closer look at it, it's still there, but then this time, instead of having this piece of logic that says filter, whatever, we just extracted it into a function, right? So now what happens? So now we have this thing called potential attendees. This is a function inside a different file. It's called users.kt. So this is the name of the function. It returns a list of users, and then it is an extension function. So you can call it on a list of users, right? And then the entire business logic is this one line, right? We are saying, hey, just find out users who have RSVPDS or who have RSVP maybe. Like this is the only thing that we are going to test. So now, again, we are in the same situation where we have to write 5 different tests. So these are all the 5 different scenarios that we need to deal with. So we have no registrations, yes, no, maybe, and whatnot. Right. So first thing that we're going to do is we're going to test no registrations, right? Like how do we test no registrations? We're going to create a new test. It says no potential attendees for an empty list. So in that case, what happens is we start with a list of empty list, which is like we don't really have any registrations at the first place. And then the second thing that we're going to do is we're going to like call this function that we extracted from our event manager, right? And the third thing that we're going to do is we're going to say, hey, the potential attendees are empty, right? So that's the business logic, and that is what we're going to test, right? And in this case, there are a little bit of improvements. The first thing is like the setup is a lot smaller than what it was with the previous scenario. And second, like the when statement is also like the same. And the assert, if you notice, we have only one piece of only one assert statement that asserts the condition, right? So unlike the previous scenario where we had like multiple assert statements, we are not dealing with multiple multiple assert statements anymore. So now let's go ahead and see how a test with a mix of yes, no, and maybe looks like, right? So now we have this thing. We have a potential list that contains registrants who have RSP yes or no, maybe. So here, so this is the name of the test. Now we're going to look at this, right? So here we have a list of users. Some of them have responded yes, some of them have responded no, and like this one person was responded maybe. Again, we're going to call like potential attendees, and then what we're going to do here is we're going to test that against a list of expected outcome, right? So this is what is going on here. So now if you look at this, again, we have written 2 different tests and they look very similar. And I'm not going to write like the test for all the other 3 cases. So we're done. So now, like you are already suspicious, right? You may be asking, hey, Raghunath, we're supposed to test the event manager, but then you have not tested the event manager, right? And that's a valid point. But hold on for a second, we'll come back to it again. And now the kind of tests that you've witnessed right now, they're called value testing, right? So when we talk about value testing, what we see here is an input, and then we have an output. and then we have something in between, which is your system under test, right? And this is a circle. I have not labeled it anyway because the system under test could be anything. It could be a function, it could be a class, it could be a method, it could be anything, right? It doesn't really matter as long as it takes an input and gives you an output. That's all what we want. So now, if we talk about collaborators, this piece of business logic that we extracted, that does not have any collaborators, right? Like it does not depend on the DAO, or it does not depend on the mailer, right? It doesn't depend on anything. And we use real things. Like say, for example, we have a list of participants who may have replied differently based on their current situation, right? Like it could be yes, no, maybe, or whatever, right? And then we are also checking it against a list of real objects which contain the user's email ID and RSVP, right? So we're using real things. We're not using like things that mimic real world, mimic real things. We are actually using the real things. So now what's with the new event manager design, right? So the first thing it does is it does not encapsulate the business rule here, right? Like the kind of rule that we encapsulated in the previous case, which looked almost innocent. We're not putting it inside, right? We're just like having one level of interaction, which is a different function on a different file. And that's the only one level of interaction, but then you'll also see how it can affect the entire range of tests that you're going to write, right? And since we are not encapsulating business logic, we can write these small tests, and these tests are called micro unit tests because they're like really, really small and they're also easy and fun to write, right? So we use this terminology as micro unit tests because in the industry, when people talk about unit tests, like we don't really have like a really agreed upon understanding of what a unit test is, right? Like it can mean different things to different people, and it can mean different things in different organizations and even in different teams, right? So that's why we specifically use this term called micro unit tests, which are like very short. Like I'm not going to put like a number on it, but then if it is very easy to set up, like maybe a line or two, if you can exercise the test within like a line or two, and if you have like possibly one assert statement, I would probably call it a micro unit test, right? And that's my definition of micro unit test, and probably Cheepa Hill also has a very similar definition of a micro unit test, right? So we are using this terminology micro unit test to distinguish between a unit test, like which has not a really like well-defined understanding or like a well-defined agreement on what a unit test is, versus a micro unit test, right? So explicitly using the term micro unit test here. And then value in and value out results, right? So the input is a value and output is a value, and it does not depend on other objects, right? So when you talk about value and value out, I want to call out event-driven architectures that are out in the wild, right? Like basically like all the systems at scale, the web, these are all event-driven systems, right? Like you don't really know who's sending you the events. So that means you don't really have to worry about who's sending it. You just have to worry about the event itself. And when you're sending out a value, you don't really need to know who's receiving a value, right? So in that case, you have this advantage of being completely ignorant about who your callers are and who your consumers are, right? So that gives you an advantage to focus really on the contract that you want to fulfill, right? As long as someone gives you something based on a certain contract, you're going to like adhere to the contract, which means systems are much more easier to design. And then there's no dependencies for business logic, right? The business logics normally can have like a lot of branching, right? And they have a lot of branching, dependencies don't mix well together, right? So that's why if you have business logic or business rules, it's always good to minimize the number of dependencies that they have, so that you can one, have tests that are a lot simple to write and maintain, and number two is you can write or you can maintain them a lot more easier than business rules that have like a lot of dependencies in them. So testing the business logic. So this is how it looks like, right? It's pretty much the same thing. We have one assert statement, and almost all business, like it's not almost, like all of the business logic can be tested with just this one assert statement, right? So it's just different variations, but it's just one assert statement. And testing the coordination logic is going to look like this, right? And I'm not going to scare you with this here, right? This is essentially the test that we wrote for the first implementation. But then the first implementation, it looked like a smaller because I extracted out all the duplicate logic, right? Like if you look at this is your setup logic, right? So in order to test a piece of, to test your condition, you need to have mock DAOs and mailer. You need the real event manager. You need an event. You need all the registrants, right? And then you also have to set up the DAO, right? So this is the exact same thing that we did with the first implementation, but it had duplicates removed. This does not have duplicates removed because this is the only coordination logic test that we're writing. So we don't really have to duplicate it, right? And that one line of code that one line of change that we made actually has changed how we write most of our tests, right? And then we have the when, and then we have the then, right? So the micro unit tests help us test all the business logic thoroughly. And then this coordination logic test, which is basically a complementary integration test, is helping us ensure that these different pieces are working together in the way they are expected to work together, right? So that's the thing. Now let's make a comparison between implementation A and implementation B. So if you're looking at the implementation, if you're going to test your business logic, most of the tests are going to look like this, right? And this is why most of the times developers say tests are hard to write, or like they're boring to write, and like they're hard to maintain, right? Because if you have production code that does not have a good design or like a maintainable design, you will eventually end up writing tests that would look like this, right? Of course, you can remove the duplication and then this would look like a smaller, but then that does not change the fact that there is enough knowledge and complexity involved for the maintainer to understand before they can maintain these kind of tests, right? You're writing like tests that are longer, larger, more complex, and imagine adding one more dependency, which means then like most of your tests are going to change again, right? And here is the kind of test that you're going to write when you've extracted out the business logic, right? And this is not something random. We'll talk about like the kind of principles, at least briefly, that are in play when you're designing like two different implementations. But this is a deliberate thing. It's not like, it's not luck. It is not random. It's like how you can consciously design systems that will help you write tests that are like a lot more maintainable, a lot more fun to write, and give you a lot more confidence. So first, implementation. So we wrote 5 integration tests to test the business logic, right? But with the second implementation, we wrote 5 micro unit tests to test the business logic. And we also wrote 1 complementary test, right? Because I call this complementary because it tests things that your micro unit test did not test, right? And this is only 1 integration test, which is a large test to test if all the pieces are working together in the way they are intended. And then it has like a lot of dependencies, and this one has fewer dependencies, right? And you can quantify that if you just look at the tests for your business logic for implementation A. You can just look at the number of import statements, right? So look at the number of import statements on the test framework that we're using, and you can also look at the number of import statements on the software system that we've built, right? Like whatever starts with XYZ or Raghunath, right? And then here, when we're testing the business logic, like it's still the same. Like we only have few dependencies on the test framework, and we also have only few dependencies on the system that we are building itself, right? So when testing the business logic, you can see how decoupled the business logic is from the rest of your application code. And then increased coupling, obviously, like if you have more imports, like then the coupling is high, right? And I just want to show you how coupled implementation A versus implementation B are. And here you can just see how these classes already are a hairy ball of mess, like competing with, like dealing with one another, right? So testing your business logic in the implementation A way versus the implementation B way. And then wider change propagation, of course, like if you're going to change the way the definition of what a potential attendee is, chances are your tests could fail, right? And if you're changing your production code and if your test codes are failing, which means those are coupled, right? And there is a terminology for this. It's called test covariance, which means your production code and your test code are completely dependent, right? So what you want is you want to be able to change your production code without changing your test code, right? And that is called test contravariance. And that is possible when you minimize coupling and when you also minimize the structural the structure of your test from your structure of your production code, right? So basically, you can decouple the structure of your test from the structure of your production code, which means like when you refactor or change your production code, your test will not be affected, right? There's a nice article, I think like it's by Bob Martin. You can look for test contravariance. And then that'll talk about like how you can write tests that are like a lot more maintainable, and the principles go behind the principles that go behind writing achieving test contravariance, right? So this is limited change propagation, right? You can independently evolve two different things, the event manager and your business rule, without affecting one another. So obviously harder to maintain because you're writing more code, you have more dependencies, etc. These are easier to maintain. And most of the time, if you're complaining about tests, you should probably go back and revisit your tests, look at the number of import statements that they have, look into the kind of assertions that you're making, the number of assertions that you're making, the number of ideas you're asserting, right? So that'll tell you like the quality of tests that you're writing, right? And oftentimes when I go work with organizations, people say, hey, you know what, like we have started writing tests, so like we should not have problems, like problems should have magically disappeared, right? But that's not the case, because if you write tests on a poorly designed system, it's only going to make your life miserable. Like people will avoid writing tests, people will check in tests that are ignored, people will not write tests, right? Because like that is the design is forcing you to write tests that are hard to maintain. Again, more assertions versus fewer assertions, right? All right. So now, if you look at it like left and right, you can see clearly like the design that we have, which is the implementation B, is like having a lot more advantages over implementation A, right? So which is the design I prefer, and this is what I try to replicate, right? Now, I also want to take you to, I also want to recommend a talk. This is a talk called Boundaries, because whatever I show to you right now may look very trivial. It's like, hey, like you extracted one function, like what's the big deal, right? So that's not it. So what we did was like we designed the way how the boundaries between different pieces of the system, right? So that's what we did. And this talk, Destroy All Softwares, by Gary Bernhardt, talks a lot about boundaries, where you can explicitly model values as boundaries between components, right? Which means you can design systems that are like a lot more easy, testable, and maintainable, and are also scalable. So that's a talk that I highly recommend. And he also talks about how you can use like architectures from the functional world. Like how do you create a functional core and then an imperative shell, so that way your system can also be more maintainable. And these are also the systems that favor test-driven development, right? So what did we learn so far? So we learned about behavior testing, we learned about value testing, we learned about micro-unit tests. We also talked about like complementary tests, where you have a set of tests, but then you also write tests that can verify parts of the system that your micro-unit test did not verify, right? So this is one of my favorite patterns, where I tend to write like a lot of unit tests for business logic, but then I also go ahead and write a bunch of tests that complement this business logic. So all these tests work together. So if you're looking at the code, it's not evident, but then once you understand the philosophy behind why certain tests are written in a certain way, then it becomes like a lot more easy to design systems that have well-tested logic, and then that also has enough integration tests to keep your software working in a nice fashion. We also looked into integration tests, and yeah, that was the first scenario, right? Like that's the scenario that we dealt with. So now I'm going to talk a little bit briefly about a different scenario. So let's say you've been hired by an organization, and then they give you a piece of code, and it does not have any tests. It's complicated, and the previous developers who have worked on this piece of code have left the organization, right? And now you're expected to build a new feature or extend a new feature. I think like this is not an unfamiliar story for you. Like most of you would have come across the situation, and probably are in this kind of situation right now. So now let's take a look at it. So this is a piece of code. Like don't even bother trying to understand what's going on. You just like look at the indentation. So this is from a programming kata, and like in production, like I'm sure like you would have seen code that is more complicated. I've come across code that is more complicated than what I'm showing here right now, right? So this is a piece of code, then you're supposed to maintain it, right? And for those who have already tried, like, okay, you may have realized, okay, if I'm going to change this piece of code, probably I should get it under test, right? And you're trying to write tests. And one of the critical mistake, like when you do this is we start writing unit tests, right? So in the previous example, you saw how we wrote the production test, and the second time we started writing the unit test, right? And there is a difference when you're writing tests for the code that you wrote, because when you're writing tests for the code that you wrote, you know what are all the cases that you need to solve for, right? So you have a good understanding of the system. So you can say, I'm going to write tests A, B, C, D, and E, and then I'll be done, right? That is fairly easy because we understand the system already. What is more hard is writing tests for someone else's code, right? So we call these characterization tests because we write these tests to understand what's going on, right? And you cannot use the same methodologies or the tools to write tests for someone else's code, especially if it is something that you don't really understand, right? And this is a common pitfall where like we learn that if you want to change code safely, you have to write tests, and then we start writing unit tests, right? And the way how we write it is we try to look into a piece of logic, and then we try to understand what it is doing, and then we try to write a test. And then like we have a bunch of tests, and then when you start refactoring, then like everything falls apart because now there are like too many things that you have to deal with. There are too many unexpected things that have come up. So it's hard, right? So what do you do when you are in a situation like this, right? When you're in a situation like this, one, you have to change the way how you think. So first is like, don't care about the logic. Like you don't really have to understand what this person's code is doing, right? What we have to do is we have to make this code enough so that safe enough so that we can go and make the change, right? Sounds kind of wishy-washy, but then like we'll go and see how we do this. So here is a test that I'm writing for the system, right? So I want to test this. So like I did not understand the system at all, right? So what I did was I looked into the source code and then picked up all the constants. So if you look at the item name, that's aged breed. So that's a constant that I found in the file, right? I don't really care what happens or like how it works. And then there are also a couple of parameters that I found out. Okay, like there's something called a selin, and there is something called as quality. And then when I looked into the code, I saw these numbers. These are hard-coded numbers in the code base, right? Like these are not numbers that I thought of. These are numbers I directly picked up from the code base and then I put it inside selins, right? And when it comes to qualities, again, I did the same thing. I looked into the code base. I found out these constants and I just put them over here, right? So the next thing that we are doing is, okay, we have these parameters. We know we have a fair idea of what the parameters could be. So the next thing that I'm going to do is I'm just going to verify all combinations, right? So there is this library called approval testing. I have a link to it later. So what I'm doing with this code, this is a code that I have not written. It was written by someone else. So what I do is I take this function, take these three parameters, and then say, hey, these are all the possible parameters and these are all the combinations. Now go generate inputs for this combination, right? So that's all I'm doing here. And like I have tilted this 90 degrees, so don't worry if you can't read it. I just want to fit in all the cases that can happen with this one item, right? So this is just one item, and then the code has like 5 or 6 different items like this. So now on the left, you see the input parameters. On the right, you see the output values, right? So what I'm doing is I'm going to like approval tests, the library itself will generate inputs, and then it also sort of like generate the corresponding outputs because like the function returns a list of items. And it just persists this onto the disk, right, as a file, right? So this is there on your file. So now what is going on here, right? So what we have done is like we did not make any attempt to understand what the function is doing. We said, hey, these are all the inputs that this function can have. And then based on this input, this is the output, and I'm going to save this in the file system, right? And that is important because if you're going to refactor this piece of code, what you want to understand is you want to be able to change the system safely without making mistakes, right? And now the next thing that I'm going to do is I want to understand if the system is safe to change, right? So the next thing that I do is I just go ahead and then run this test with coverage. And then on the right, you could see we have achieved 100% code coverage, right? Which means all these code parts are being exercised. And I showed you a approval test just for aged breed, but then like for every hard-coded string that you see on the left, there is a corresponding test with the same input on like the same input values, right? So that way we achieved 100% code coverage like relatively quickly, right? We didn't really understand, we didn't really care. We just fixed these input parameters and then we wrote this test, right? So now if I start refactoring this piece of code, then if I make a mistake, I will know immediately, right? And the way how I would know it immediately is like this, right? So I can start refactoring, and as long as I make safe transformation, either using the IDE or a provable transformation, my code should not break, right? But in case if it breaks, this is what would happen, right? So on the left, you see the behavior that we have captured, right? Sorry, on the right, what you see is the behavior that we have already captured. And on the left is what has changed, right? So you can clearly see IntelliJ highlights things that have changed and things that have not changed, right? So from this one, I can look into the inputs and outputs and probably make an educated guess telling the kind of mistakes that I made, right? And I can look for patterns. And if that is hard, I can just go ahead and like do a git reset and then say revert whatever change that I've made and then like start again from the last checkpoint that I had when I was refactoring this piece of code, right? So approval tests, some of you may have known it in through other names called snapshot testing, golden master testing, etc., etc. Approval tests can work on any kind of data. So it could work under databases. It can compare images. It can compare audio. It can compare video. It can compare 3D rendering. So as long as you have a way to like sort of look at the difference, like say for example, if you have an image diff, then you would probably like approval test will actually show you a reporter with the difference, and then you can see, okay, like maybe I made this change, and there is this pixel that's a couple of that has shifted a couple of pixels towards the right? So you can still do that with approval testing. It's so powerful, and it can also help you bring large systems under test relatively quickly, right? So fortunately, like the example that I showed you. It's called as the Gilded Roses kata. It's very popular in the, among the legacy code community. That is like pure logic, right? But then in real world, you would have like things that talk to the database. You would have things that are performing side effects and things like that, right? So it's a slightly, so in that case, you have to break dependencies, introduce indirection and things like that. But to get started, that gives you a quick taste into how to deal with code bases that you've not written or like complex code base that other people have handed over to you. So here are some of the links. The first one is the approval test of Java. So that's a library that you can still use with your Kotlin projects. The second one is a plugin that makes it easier for you to work with approval tests. So it's a plugin that I've written. So it only, I haven't added support for Java. So it works with Kotlin. So if you're a Kotlin developer and you need a plugin that helps you when you're working with approval tests, you can go ahead and like either build the plugin by yourself or you can download it and install it in your IDE. And approvals is not just for Java. You have like different implementations. There's this person called Llewellyn Falco who maintains it. He's done an amazing job. There are like different variations for different programming languages, so you can pick the one that you want. Like you can pick for .NET, Python, C++, or any other languages that you're really interested in. So go check it out. So approval testing is one of the techniques that you have to know, especially if you're working on code bases that are really hard or like legacy code bases, right? So change the technique, change your mindset, change the tool. Then things that may look impossible will turn out to be possible. So more things, tools and techniques that I've not discussed here is one, performance testing, where you probably can use micro benchmarking tools to use it. The other one is property testing. So property testing helps you with a certain class of problems. So usually when we write tests, we write example-based tests. So what we do is we say, hey, here is an example of the scenario. And when this happens, this is how the system should behave. So that's just example-based test, right? The kind of test that I've already shown you, both behavior and value, those are all example tests, right? So property tests can be tests like, say, for example, when you have two pieces of components that need to work together, like say you have a component that performs encryption and you have another component that performs decryption. So now you have to verify for all possible inputs, the encrypted text, the encryptor will produce an encrypted text. And when I pass this down to the decryptor, it should give me the original text, right? So that's the scenario that you need to type. So you could have any combination of input, right? It could be any kind of encoding. It could be any language they're using. So you have like a lot of different combinations that you need to test, right? And coming up with examples and good examples in particular can be very hard. When you use property testing for this class of problems, the property testing framework will generate inputs for you. Like it will generate these inputs automatically and also randomly, right? And the more you run these tests, the more inputs it will generate, right? And in case if it finds a case for which your system does not work, it will also try to produce the minimum input that can reproduce this issue for you, right? So what you can do is you can say, hey, okay, here is a seed, and here is a minimum input for which your system is failing. so that you can rerun the tests and you can fix your system, right? And then you can keep running this. So it helps you to build really high quality components. And the scenario where I mentioned, where you have two pieces of components that need to work together, so that is one of the scenarios that you need to work with. So that's also a very powerful testing tool. And for those who have a question that like, hey Raghunath, like you're talking about all of this stuff, have you used any of these? It's like, yes, I use all of these. Performance testing, not so much, because that's not like, most of my job does not involve writing micro benchmarking tests. I do help teams with performance, but that's a different kind of work. So I extensively use approval tests, testing frameworks like approval tests. I write a lot of tests, unit tests, integration tests, complementary tests through test-driven development. And property testing is something that I use occasionally, like maybe once or twice a year. I don't use it much because most of the systems that I built don't have that kind of requirement. So these are things that I use, and I also vary my tools and techniques based on the kind of situation that I come up with. And the other thing that I want to talk about are different kinds of workflows. So workflows are based on how you can build software. So when we talk about TDD is something that is it's a regular part of my workflow. So most of the software that I built, like both existing software and new software, they like TDD is probably like 80-90% of my workflow. There are cases where I tend to like write production code in legacy systems where I don't really have the time. And I think I'm not making an excuse here. There are times where you have to be pragmatic and do the thing that is required before you can go back and do the right thing. So probably like that's very little, like the kind of time that I touch the production code without having tests, that's like probably very less. So those are cases where I don't use TD, but otherwise like most of my workflow involves TD. And TD is something that's very hard for people to learn on their own. So either pick a buddy with someone who you can pair up with and then learn TD, or go attend one of these events by Code Retreat. Venkat Subramaniam actually runs these, or he used to run these when we were not under this current situation. He used to be in India, and he's run a fair amount of 3D sessions. And I think like most of my skills I picked up from one of these code retreats, right? I've attended almost 3 code retreat sessions, and not until like recently I didn't apply. Like maybe 4 or 5 years ago I started doing TD, but I attended a TD session long back, like maybe 8 or 9 years ago. So TD is a very powerful workflow. It's not about testing. Like TD is about design, because like this entire talk was about how design can affect the way how you write tests, right? And most of the time there is no objective way to tell what a good design or a bad design is. It's very subjective. But what TD forces you to do is it forces you to write software that is designed well, right? Because it gives you feedback on your design, right? So that is what you do. There are cases where TDD is not applicable. Those are like very far and few, but most of the cases you should be able to use TDD. And second thing that I want to talk about is TCR. TCR is another favorite workflow, again, championed by Kent Beck. There's an article, you can go look at it. And then second, there is Lars Eckhart has written this TCR extension. So Lars Eckhart is also one of the maintainers for approval testing. I pair program with both Lars and Lublin. They're fantastic people. So that is an extension that is super nice to use. It's a fun extension, because I call it fun because it currently works on Gradle, but it does not work on multi-module projects, right? So that's why I call it as a fun project. But then the kind of workflow that it gives you is super amazing. So with respect to TCR, what TCR does is it makes sure that your code is always shippable, right? So if you're refactoring your code and if you make a mistake, the TCR plugin will automatically discard all the changes on your code base, right? So you have to be very careful about the kind of changes that you're making. And it's a very fun way to like refactor code bases. And the last link is where I've used the TCR extension by Lars, and I've refactored Gilded Roses to a more object-oriented approach. So there are like a lot of commits you can see. These are all micro commits. So that can hopefully give you some idea about how a TCR fueled refactoring could look like, right? So what we would do is you would first bring your entire code base under test, and then you start refactoring. And if your refactoring did not affect your test, which means you have not broken your existing functionality, the plugin will automatically bring up a dialog and it'll ask you to commit it. So that will commit. And then the next thing you can do is you can just make the next change and then save it. And then like the plugin will kick in again and then see if the commit is good, it will check it in automatically to your Git repository. If not, it's just going to discard everything, right? It sounds scary, but then it's something that you should try. The more you try, you can really understand the philosophy behind why we need more workflows like this. So workflows are a way for you to build and manage existing software. So these are workflows that I think are worthy of your time to evaluate, especially if you're going to be in your software building career for like a few more years from now. Something worth uh, experimenting with. It doesn't really matter if you succeed or fail, because regardless of whatever it is, we will definitely learn things. And that's the end of building robust software, all 3 sessions. And thank you, folks, for being here today. And if you have any questions, I would be more than happy to answer. And the slides will be available shortly. You can follow my Twitter account. I would tweet these slides so that you can take a look at them. And hopefully, like, these recordings will be there. So if you find it helpful, and if you think your co-workers would also find it helpful, feel free to share it with them. And thank you very much.